Hello guys, in this video I'm going to show you how to implement and simulate a multiplexer in LabVIEW. So that's like a series of like three or two or three videos. The first one is a multiplexer in LabVIEW. Second video is a demultiplexer in LabVIEW. The third video will be like the implementation or the VHDL implementation of a multiplexer and simulate it like in Vivado. So let's start here by the multiplexer. Okay. So the multiplexer like basically do the following. So if you have this, let's assume this yellow box is the multiplexer. Okay. So of course this yellow box should have like AND gate, OR gate, logic gates in general. Okay. So but this is not our problem now. So how it works? So assume this circuit is enabled. Enabled mean it's operated, it's operable, it can operate, it can do the function. And this usually happens if this input enable is equal to 1. We will not use this input today, but if you see a circuit, a multiplexer circuit was enabled, this is what it does. Okay, so let's concentrate on the most important inputs: the selector, the input 0 and the input 1, and the output. Okay, neglect the enable for now. Okay, so this multiplexer is very simple, or it operates in a very simple way. When the selector, which is 1 bit here, is 0, the output will equal to input 0. So if input 0 is 0, the output will be 0. If input 0, data input 0 is 1, the output will be 1. If the selector is 1, the opposite. The output will equal to data input 1, the second input here, this one here. Okay? So if there is a 0 here, it will be 0 here. If there is 1 here, there will be 1 here. So we can basically summarize this in a truth table like that. Look at Z. Z is the output, okay? And this S here is the selector. So whenever a selector is 0, which is the first 4 states, look at the output here. 0, 1, 0, 1. And compare it to D0, data input 0, 0, 1, 0, 1. So basically when the input selection is 0, basically D and Z are equal to each other. The opposite happens when selector is 1. Look at the output now. 0, 0, 1, 1. And look at data input 1. 0, 0, 1, 1. Okay? So we want to design this circuit. We wanted to know how to, what kind of logic gates we're going to use, what, wiring we're going to connect. All this we can do once we have the truth table. And we have the truth table. Here is the truth table. Then you open Logisim. I hope I opened it already. Yes. Here is Logisim. Okay. So I already have the circuit here. I believe we can just review what's in it. If we can't, then we can just we can do it from the beginning. That's okay. Yeah, I have it here. Okay. So in Logisim here, I have a video before. You can just, in this video, I'm showing how to download and install Logisim and how to use it. But anyways, here is a review for it. So basically, we input the inputs, and it's good to, to use the same order. It's D1, D0. So it's D1, D0. Okay? You input the inputs. Like for example, if we want to add another input, just X, for example, add, here is X. But we don't want this, so I'm gonna remove it. The output, we have just one output, which is called Z here. And then you feed the truth table of the circuit. So look, that's why the order is important. So you have the same order here also. SD1, D0. And it's the same truth table. Then you feed the output, of course. It will toggle between 3 values. So 0, 1, and X. X means don't care. It can be 0, it can be 1. Of course, we want a 0 in the first one. And of course, I did it before. So we have 0, 1, 0, 1, 0 1 0 1, then 0 0 1 1 0 0 1 1. Okay, and then you build the circuit. You give it a name. Okay, already we have it. So it will give you the expression, and the expression is S bar D0 plus S D1. Okay, and that's the equation basically. I believe, yeah, and of course, once you do that, once you build the circuit, it will give you the circuit as well. So we have here the circuit. We just implement it here. Okay, so let's implement it. So in LabVIEW, you're gonna create a new project, okay? And once you create this new project, you go to the VI, window, which is one on the far left here. Right click, the control wizard will appear to you, and from Boolean input, you choose vertical toggle, this one here. Like for example, here is one, because it's running. So let's stop it. So vertical toggle, we choose one of them. Here it is. Okay, you name it like D, for example. You can resize it as well. Okay, then copy and paste 3 times because we need 3 inputs. We need S, D1, D0. Okay, of course, you might say the selection is input. Look, usually we draw the inputs on the left here. Yeah, that's correct. These are the inputs. Okay, but the selection, it's a virtual. You can say it's a virtual input. It's an input at the end of the day, but it's a controlling input. It control how the circuit will behave. If the selector is 0, again the output will be equal to D0. If the selector is 1, the output will be equal to D1. So it's like a control more than an input. The inputs are usually these guys. Okay. Anyways, we're gonna call it input. So once you create that, like a replica basically will appear for each one, for each module that you use here in the block diagram window, which is the one in the middle here. Then you connect. Okay, let's, for example, like I'm gonna remove one of those like links. Gonna connect it again. So as you see here, yeah, how to enter so the AND gates, right click again on the block diagram window, and then it chooses Boolean. In programming, it chooses Boolean, and then enter the and we need also an inverter, and we need also OR. So we have 2 ANDs here, 1 inverter and so on. Remember the expression, if we bring back Logisim, the expression is S bar. So this is S, so that's S bar after the inverter, ended with D0, that's D0. So that term here is S bar D0, this one. And then we need SD1, this is S, and this is D1, so this guy is SD1. Then we OR them together using this OR gate, and that will be the output Z. And the output here, I forgot, it's just like an indicator around LED. Okay, like this one. Okay, although we don't need, we already have it. Once you have that, you basically run continuously like that. Okay, so it's running now. Let's now verify the truth table. Okay, so when we have the selection equal to 0, and D1 0, D0 is 0, I mean all of them are open switches, then the output will be 0 because D0 is 0. Still S0 is 0, D1 is 0, but D0 is 1. Oops, Z is 1. Okay. Then third case, 0 here, 0, 1 in D1, and 0 in D0. The output will be 0. Finally, 0, 1, 1. We have also 1. I'm gonna do one of these, like for example, let's do this one here. One selection, D0, D1 is 1, and D1 is 1, and D0 is 0. We should have 1 because, in this case, when the selection is 1, the output follows D1 input, and D1 is 1, so the output will be 1, and the LED will be light. Okay, guys, that's basically part one of your lab. Thank you very much for watching and wait for another videos. Bye-bye.